Assalamu alaikum. This is Muntasir. Here I present to discuss about recurrent neural networks and LSTM, which means it long short term memory. Basically, it's deep learning models for sequential data. Head slide is that understanding recurrent neural networks. What is neural RNN or recurrent neural networks? Recurrent neural networks are a class of neural networks designed to recognize patterns in sequences of data such as text, speech, or financial time series. Unlike traditional neural networks, RNN process an internal memory, allowing them to process sequence of arbitrary length by maintaining a hidden state that captures information from previous state. Here's let me see that the necessity of RNNs behind traditional limitations. Traditional neural network struggle with sequential data because they treat each input independently, ignoring the context provided by previous imports. Here, this limitation prevents them from understanding relationship over time, which is crucial for tasks like language processing or predicting future events. Sequential dependence, fixed input size, or contextual blindness. Here we see that the system for unpacking the RNN architecture. The core of an RNN lies in its ability to pass information from one step of the network to the next. This is achieved through a hidden state which acts as a memory, influencing the output and the hidden state of the subsequent step. At each time steps, the RNN takes an input and the previous hidden state to produce an output and a new hidden state. Here are the challenges of basic RNNs: vanishing gradient, short-term memory, and exploding gradients. Here we introducing long short-term memory LSTM networks. The overcome the limitation of basic RNNs, long short-term memory networks were introduced. LSTMs are a special type of RNN capable of learning long-term dependencies, make them highly effective for complex, uh, complex sequence tasks. LSTM achieve this by employing a sophisticated internal structure called a cell state and a series of gates that regulate the flow of information, allowing them to selectively remember or forget data. The power of LSTM gate. LSTM networks utilize three case gates to manage the information flow within their memory cells. Number one, forget gate, input gate, and output gate. Real-world applications of RNN and LSTMs. The ability of RNNs and LSTMs to process sequential data has made them indispensable in various cutting-edge applications: speech recognition, text generation, machine translation, or time series forecasting. Here, the constellation mastering sequence modeling RNNs fundamentals for processing sequence by leveraging internal memory through hidden states. LSTMs address RNN limitations, especially vanishing gradients with sophisticated gating mechanisms for long-term dependency learning, and it is a great impact. Thank you. Thank you for all.